distribution, you already know that that's a bell curve we're talking about. But I want to say a couple things. When you see the word standard normal distribution, that implies a few things. First of all, it tells me that mu equals 0. By the way, what does that, tell me what that symbol means again? The mean is 0. That's automatic if we say standard normal distribution. We're talking about mean 0. By the way, that means on the picture, for this number 10, you guys will notice I had 1.08 right here, and I had 2.30 right here. I didn't draw it, but I could have told you right in the center, what value is that? That's 0, because that's the mean. The mean is a measure of center. Does that make sense to you guys? Okay? Second thing is, I'm going to write this. Sigma equals 1. That's a lowercase sigma. By the way, what does that stand for, that lowercase sigma? That's standard deviation. Standard deviation is a measure of what? Distance from the mean. Yeah, it's telling you how spread out stuff is. And I guess one last thing you guys should know is that these numbers here, these are what we call z-scores. Z-scores. Those are the number of standard deviations we are from the mean. Okay, the number of standard deviations we are from the mean. And so when I say that this is 1.08, by the way, one standard deviation is right where you're at, like the steepest part of the roller coaster. Maybe right about there. This would be sigma, right, equals 1. But these z-scores, when we measure z, right, I'm actually going to call this the z-axis, right? I'm measuring how far away from the mean we are. That's what I'm really measuring. Okay? Now, then we're going to find how much area is here, right? That's really what this is all about. So it turns out that the process in the calculator is not hard, but what I want to make sure you walk away with here in the next 15 minutes is you understand what it means. So I'll show the process first. John, you were asking me, hey, what do I do with this calculator, right? Let's do this. So I'm going to pull out a calculator. And I showed it last time just briefly. We only have a few minutes after a quiz, right? The command I want is normal CDF. What does the C stand for? Cumulative, because you're adding up kind of lots of different possibilities, right? I'll tell you what I'm really computing here. Remember I said find the area, right? When I said find the area of this, we understand that that area is equal to probability. We're really finding probability. And so if I wanted to use the language of probability, here's what I would say. I would write this. How would I read that? That's the probability that z is, how would you read that? Well, I guess maybe the fast way to read it, say z is between 1.08 and 2.30. And the way I compute it is this. On the calculator, again, normal CDF. How do I get to that? Do you remember what to hit? Second. Yeah, it's right over here above variables, right? And I think it's choice 2, because choice 1 is normal PDF. We want normal CDF, okay? Now, my calculator is newer, so it gives you a menu. If you don't have that, all you have to do is type in the lower bound, comma, the upper bound. So for us, for our problem, what are we going to type in? Well, we're going to type in 1.08. The lower bound is farther to the left. And for the upper bound, what am I going to type? 2.30, right? Or even just 2.3. We want to make sure that our mean is 0 and our standard deviation is 1. That's automatic. If they say standard, or if you're talking about z-scores, automatically we mean the mean is 0 and the standard deviation is 1. I'll paste that into the normal window. And it says, what's that probability or what's that area? 0.1293, right? So if this is a probability problem, and I say, what's the probability of getting a score between 1.08 and 2.30? Well, it was about 13% chance of that happening. About 13% of the data is in this region of the bell curve. That's kind of what it means. It is how they get percentiles. That was mentioned in your homework. I want to do one of those problems with you in a minute. Here, let's go to the last one, number 16.
I got 0.1188.
You got a different score?
Yeah.
Oh, yeah? Let me pause for a minute and see why. Brandy, did you get the same thing? So we were working on the next problem from the group work, and we had negative 2.13 here, and we had negative 1.23 here. So again, remember the mean is 0. Right? Mean is 0.
When you start making probability statements, how come you don't do less than or equal to?
That's a good question. Some books do less than or equal to. It won't change the answer.
Okay, just based on like how it looks, you would think it would be less than.
Yeah. If you want to put less than or equal to, you'll get the same answer.
Okay.
It won't change the area,
Yeah.
just to whether or not you include one little thing. So negative 2.13 goes here. Negative 1.23 goes here, right? And so we're going to try it. Let's see if I got the same thing you guys do. I'm going to hit the same thing, right? Second entry, negative. So if you have normal, let me not do it that way. Let me do it the menu way. So make sure you guys use this negative sign down here. We learned that the hard way, right? Negative 2.13 is my lower bound. And then you have to use the negative down here, not the minus sign. Negative 1.23 is this guy. I'll paste it in. So I'm getting something wrong there. Try that again. That's not what you guys got, right? How do I know that I made a mistake? It's a probability, right? What's wrong with this number? It can't be negative. But look what I did. I typed something funny up here. I typed normal, normal. So we'll try again. Second variables. Okay, we go to that normal CDF menu. Does that look right now? I think so. Paste it in. Enter.
Yeah.
Anybody else get that? So under 10% of the area, right? This would be 0.092. If I round, I'd say 0.0928, right? So about 9% of the area would be between these z-scores. Now I have two other things to show you. I skipped number 12. I want to go back to it, right? Number 12 on the group work said this. You had this picture. But what's the issue is they only gave you one z-score, right? So here's 0. So where's negative 1.14 is here. Sarah, you have a question? Okay. So it's the probability. So how would you write this? What are we computing here? I might say this. We want z to be less than negative 1.14. That's what we're computing. And greater than, it doesn't say, right? So one issue here is I don't care how low it is. I just want it to be lower than negative 1.14. It's important you understand how to do that. So on the calculator, well, I'm going to go here. I'll hit second distribution again. I'll hit normal CDF again. So choice 2. What do I use as a lower bound? Well, the answer is you need something really negative. Someone asked me on Friday, well, how negative? And I said, I'll talk about that. And the answer is, this one works well enough. If I hit, well, go ahead, type in any really negative number you want. I'm going to type in negative 5. That's negative enough. Some people type in negative 1,000. Some people type in really negative numbers. I'm telling you negative 5 is enough for a standard normal distribution. Now, what's my upper bound going to be for this one? Well, it's going to be negative 1.14, right? So I got to type in 1.4. I still have a mean of 0. I still have a standard deviation of 1, right? Paste. Did you guys get about 12%?
If we were to put a negative or a lower negative number, we'll still come out with the same thing.
Let's try it. What did you use as your really negative number?
Well, when I do it, like when I go into this, it just shows up automatically as lower as negative 1 times 10 to the 99.
Yeah, negative 1 times 10 to the 99th. You know what that is? That's like negative 1 with 99 zeros after it. I mean, did you get the same answer, or was yours a little different?
No, it's the same.
It was the same. Okay, that's what I'm saying. As long as you have something really negative, like if I threw in negative 100, right? I'm going to get, I think, the same answer. Is it exactly the same? Yeah, I guess, it's negative enough. Well, no, it's not exactly the same. Do you see? The millionth place, I disagree, right? But the first 5 digits are the same. And after that, I mean, who really cares at that point, right? Now, why does it work? Let me explain. On the picture, right? Think about what we did. What did I use as my lower bound? I used negative 5. What did Sarah use? She used negative 100, or it was even smaller than that, right? But what happens is this curve, remember I talked about an asymptote? It gets really, really, really close to the z-axis, right? And so at that point, if you move farther left than about negative 5 standard deviations, there is so little area that it doesn't matter. Translation. It is extremely unlikely to be more than 5 standard deviations away. Remember, z-scores are standard deviations. That's something we want to understand. Z-scores are standard deviations. And so, yeah, lower bound of negative 5 is plenty for a problem like this. Or if you have sometimes we'll say, what's the probability of z being greater than something? An upper bound of 5 or 10 is fine. Okay? You'll get the same answer pretty much that we would. Amy, question?
I keep getting an error.
You're getting an error? We got to take a look at that one. Did you hit go to? When you get the error, you have the choice of either quitting or going to. Try that. Try going to the error. I want to see what you get. I have to write down my answer, guys. What did we get as an answer? 0.1271. 0.1271. When you did go to the error, Amy, did you try that? Where did it put the cursor? I can't hear you. I'm sorry.
Got it.
You got it? Was it a negative sign?
Yeah.
Let me show that to everybody, because that comes up a lot. I've seen people do this. They'll type in, the same thing, but a common error would be, right here, instead of typing the negative sign, right there. Sometimes people use the minus sign. And for some reason, your calculator can't handle that. If you do that, there's going to be an error. But anytime I get an error, if I have the choice to go to the error, I always do, because then I can sometimes figure out what I did wrong. And it's going to put me, yeah, it says it doesn't like that negative sign. So you have to hit the negative sign here below the 3. And as long as I have both of those, then it handles it. Yeah, always go to errors in computers or calculators. That's a good idea. There's one more we didn't do yet. I thought we should try doing number 14 on Excel so that we're learning both kinds of technology. All right? So let's try to do it, right? And your book talks about how to do this on the homework. They have a little write-up. Did you guys see that? Let me jump there. Here's the book. And this was from the homework last night, or actually this is from the homework for tonight. But they always have these blue boxes. You guys have seen these? These blue boxes are going to be more and more important for us. Because as we're getting into real statistics, we're going to want instructions for the technology. And so I'm looking at Excel. And it says finding area. That's what I'm doing right now. To find the cumulative area to the left of a value, click on FX. All right, so we'll try this. I'll try and follow those instructions here. So if you guys could launch Excel on your computer, you could follow along with me. Okay? Oh, I better write down the problem. While you guys are launching Excel, I still have to write down the problem. I didn't do that yet. All right, so from the group work, we're doing number 14. Oh, by the way, I didn't show you something. I wanted to. Hey, before I do 14, I'll show you one more thing. We're gonna play Guess the Answer. Ready? So, you guys, let's see if you can guess the answer. What if I did, instead of negative 100 to negative 1.14, what if I did like this? I did, guess the answer, negative 1,000, comma, positive 1,000. Any guesses what the answer is going to be? Let's see. It says 1. Why? What did I just find the area of? From negative 1,000 to, let's draw the bell curve like that. What did I just find the area of? Wasn't it a bell curve that kind of looked from negative 1,000 to positive 1,000? So I was just finding the area of the entire bell curve. Are you with me on that? Do you see why it has to be 1? Because areas are the same as probabilities. What's the biggest area we can get? 1. What's the biggest probability we can get is 1, right? I guess 0 would be if somehow you didn't have any area. But if you pick 2 numbers, you're always going to have some area. Here, try this one. Another guess the answer problem. I bet you all get it, though. Ready? So what if I said, I'm going to do the same problem. Instead of going from negative 1,000 to positive 1,000, let's go from negative 1,000 to, here, I'll delete a couple, to 0. What do you think the answer is going to be? Talk to each other about that for just a second. What do you guys think the answer is going to be? My calculator's wrong. You guys are actually smarter than the calculator here, right? I mean, you're right, the answer should be 0.5 or 50%, right? The calculator, however it did it, is actually off a little bit in the, what is that, billionths place? I don't know what it is. But it's basically 50%, right? Because, why? Well, because half of the area is on one side and half of the area is on another side, right? So I could say, for example, in the problem we just did, the probability of z being less than 0 is 50%, right? We just computed that. Okay, back to 14. 14, the z-scores I want to be between are, let's see, negative 2.88 and positive 0.35, right? I want to be between those z-scores. Oh, here's a question. Do you predict that our answer is going to be less than 50% or greater than 50%? Talk to each other about that, again, for about 20 seconds while I punch up the answer. I want to try and do it on Excel. I haven't done that yet. It says, the book says, press the FX button. Let's see, do you see the FX button? I don't either. Oh, you see it? Yeah. Oh, yeah. Right here, guys. Do you guys see what we're going to press right here? Right near the white screen. Try this on Excel. You ready to press it? That little FX button right there? Boom. And that types in equals, but then it also punches up this crazy thing. All right? And then the book says, let's see what it says next. I think it's going to tell me which package I want, statistical or something. So let's look at it. Back to the book. It says, yeah, select statistical and then norm dist is what we want. We really want norm dist. Let's see if we can get that. Search for a function. I'm just going to type norm and see if it knows it. Norm dist. See if it'll get that for me.
Norms.
So it is norm, N-O-R-M, and then D-I-S-T, not norms. Norms is different. So norm dist, I'm going to double click it or press OK. I think I'll double click that right there, that blue one. So there's the function, normal distribution. And then it says of what? What do you want your x value to be? So, or do you want cumulative? We want cumulative, right? Because we've been doing normal cumulative distribution. By the way, so I'm not going to put anything for the x value yet. Well, let me follow the directions. Maybe I will. Maybe I'll have to put it with a comma. It says, in the dialog box, enter the value for x, enter the mean and standard deviation, and enter 1 in the cumulative space. I see. So here I go. So for the x value, I'm going to do 0.35. Okay. And then I'm going to hit the tab key. That'll put me down to the next box, the mean. What do we want the mean to be? 0. What do we want the standard deviation to be? 1. And then do I want cumulative? This is kind of weird. You have to either say yes or no. If you want to say yes, we're doing cumulative distribution. I'm going to hit a 1. And this is not going to give me the right answer, unfortunately. Here, let me zoom in so you guys can see what we just got. This gives you part of the answer in a sense. Right? It gave me 6368. But did anyone do it with the calculator? What'd you get? 6348? Yeah, I think that's correct. Let me show you why. On the next line, down here, let's kind of repeat the process. Let's hit the function key again, or press equals, either one. No, I'll just do it with equals this time. Oh no, I'll hit the function key. That's what they said it in. So equals, I want norm distribution again. Oh good, it's right there on top. What do we want x to be this time? I'm going to say negative 2.88. That's the left-hand limit, right? The mean should be 0. The standard deviation should be 1. Do we want cumulative? Yes, so what do I hit? A 1. Enter. And it says that my answer is, well, you know what that is? That's about 2. Well, about 0.002, right? So I'll tell you how you get your answer. And for those of you that did homework with the tables, you might have been doing this last night, perhaps. You have to do things like this. To get the correct answer, you would have to say equals, let me click on the first guy, minus, and let me click on the second guy. Enter. Is that the answer you guys got with the calculator?
Yep.
0.6348? Well, that's kind of annoying to do on Excel. I like the calculator better for this. But I'll tell you what we just did. Okay? When we did that process on Excel, let me show you what we did. See this picture? That's what we're trying to get, right? So the first step, remember the first x value we typed in was what? The first x value we typed in was 0.35, right? And so we found this area, including that tail, if you call it. I sometimes call that a tail of a bell curve. But then we wanted to subtract this green area right here, right? So the second step was find the area to the left of negative 2.88. And then I subtracted off that green area, and I was left with the area I wanted. Does that make sense? I think the calculator is easier, the way it's set up. But it's good for you to see both, I think.
How do you do it on Excel if a lot of times when you do it right?
So give me an example. Well, here's what I would do. Say we want to go to the right of,
12.
number 12? Yeah, that's a good idea. So back to number 12. We did the numbers to the left, and it gave me 0.1271, right? Actually, so 12 would be easy on Excel, right? Let me do that. If I do Excel and I want to do 12, what do I do? Equals norm distribution. I didn't like that. I don't know why. Because I didn't select it. I'll double click it. And if I type in number 12, what was the number? It was negative 1.14, comma, and I'll type in 0 for the mean, 1 for the standard deviation, 1 for cumulative. If you type this in, or if you use that little menu, that's the answer we had for number 12, right? You know how I would get, so here's Sarah's question, just so everyone understands. Sarah said, hey, in number 12, what if you had to find the area to the right of negative 1.14? Well, how I would do it is this. The total area is what? 1. So what I would do on Excel, or if I were using the tables, is I would say let's do 1 minus the area we just found. I'll take 1 minus that 13% and I'll get about 87%. Does that make sense? 1 minus that. I'm using the complement idea. I'm going to stick to the calculator for the rest of class. I think we'll be happier then. Okay? So there was one homework question you guys had last night, or a couple, where they asked about percentiles. I gave you an even one. Was it number, well, let me see. Let's go back to the book. 36? 46, yeah. That's a good exercise, 46. Although maybe now we can do it. Let's see. What page was that on? 258, thank you. Now here's the start of the homework. Oh no, there it is, 46. About blank percent of the area is between z equal. Well, now you could do this problem, right? What would I type in if I want to find out what percent of the area is between -2 and +2? Well, we're going to go here. Let's use the calculator. It's a lot easier, right? Second distribution. Normal CDF. And yeah, let's type in negative, wrong negative sign for me, -2. And then for the upper limit, we want +2. What percent of the data is between -2 and +2? And that answer is about 95%. Right? 9.9545. By the way, those of you that have been using the tables, the pull-out cards, if you look up from -2 to +2, this is an important value. This 0.9545 comes up again and again. And again, the picture is this. The area, the probability of z being between -2 and +2, what I'm saying is most of the area, here's mean, equals 0. Here's 1. Here's 2. Here's -1. And here's -2 standard deviations. Most of the area, how much? About 95% of the area is within 2 standard deviations of the mean. 95%. Right? What that means is, do you remember back in chapter, I think it was chapter 1 maybe, or no, chapter 3, where we said it's unusual to be more than 2 standard deviations from the mean? Well, why do we say that? Because you guys, what would be the probability of being outside of those bounds? If it's 95% chance of being inside the bounds, outside the bounds, there's only 5% left, right? 2.5% of being on one side and 2.5% of being on the other side because of the symmetry. So when we say it's unusual to be that far away, that's because 95% is the chances of being inside. Only 5% chance of being outside. And sometimes we're going to say 5%, that's unusual. Okay? Any questions on that one? What's the one you guys had to do for percentiles? I wanted to do that. You guys had one like that. It was on the previous page. Where'd you guys get it? No? Did I give you any from these finding critical values? Or no? Maybe not. So we're going to try problem 38. You guys see what it says? I'll zoom in a little bit. It says find P5, the 5th percentile. This is the bone density score separating the bottom 5% from the top 95%. It turns out that when you get your bone density score, if you ever, my mother actually gets these because my mom has osteoporosis. How many are familiar with that? People didn't drink as much milk when they were young, and there's a lot of reasons. But anyways, sometimes you see these older ladies start hunching over, right? And it's usually the bone density they're losing. So that's why they're more in danger of falls and things like that. So she has to get a test for her bone density. And what they do is they just put it on as a standard normal distribution. And so if you have a negative, what would it mean if you have a negative bone density score? What would that mean? Well, let's look at this picture. If we look at the bell curve and we say that the way they do bone density scores is they plot them on a standard normal distribution, right? That means it looks like this. And it also means, since I said standard normal distribution, right here in the middle would be what? What's the mean? 0. And they told me that the standard deviation is 1. So to the steep part of the roller coaster, that's like 1 or -1. Now, what are we supposed to find in this problem? They said, find the 5th percentile. And what that means, they're saying, find the score corresponding to the bottom 5%. The bottom 5%. Because you guys, if you get a negative bone density score, all that means is that you're on this side of the curve, right? And if you're on this side of the curve, you're in the bottom 50%, right? But maybe being in the bottom 5% is when it's dangerous. Maybe that's why we want to know. So the picture is this, guys. That's the picture. Now, when they say 5th percentile, how do you write that as a decimal? The 5th percentile? Yeah, it's 0.05. If they said 0.5, the answer would be 0, right? But what we're trying to do here, this is kind of interesting, I think. It's going backwards. We want to find the z-score, and we are given a probability or an area, right? An area is the same as a probability. We're trying to find the z-score. Was anyone able to do that last night? Find the z-score. You got it, Sarah? What'd you get? Yeah, that's what I'm asking. Oh, I don't know. Oh, maybe this is different. This is 38. Maybe I didn't assign that. Right? So, well, let's just talk about how we do it. So what we're going to do is, when you go to your calculator, and you're trying to go backwards now and come up with a z-score, here's what I'm going to do, guys. Second distribution, just like I did last time. But instead of hitting normal CDF, look what happens if you go down one more option. Do you read what that says? Inverse norm. That's telling the calculator, let's go backwards. This time, we're giving you an area, and we want to know what the z-score would be. This make sense? So what area do I type in? 0.05, sure. So let's type in 0.05 for the area, 5th percentile. Let's leave the mean as 0 and leave the standard deviation as 1, and we're going to paste things in. And let's see what it spits out. It says negative 1.645, right? So the z-score that corresponds to 5% of the area, the way I do it again is I type in inverse norm of 0.05, and the answer is negative 1.645. That's how you go backwards. I'm going to have you guys try a problem here in a moment. Ready? Let me draw a picture and have you guys do it. Here's my picture. And what I want to do this time is I want to find, let's do this. Find the 90th percentile. The 90th percentile. So let's draw the picture of what that looks like, guys. When we say find the 90th percentile, the picture is this. We want 90% of the area to be here. So question, do you guys think the z-score is going to be positive or negative? You can tell from the picture immediately. Has to be what? Oh, I guess maybe you can't tell. I was wrong. Let me try this. You guys see this right here? That's the mean, and the mean is what? 0. What I'm after, if I want 90% of the data to be less than my z-value, I'm after this z-value, right? Do you see why I think that z-value has to be positive? Because why? It's to the right of the mean, and the mean is 0. Do you guys see what I'm saying? So last time, when we had 5%, then the z-score was negative something. But this time, the z-score must be positive. Now, see if you could figure out what it is. Use the calculator and figure out what that z-score is. I'll pause for just a second. So again, inverse norm is the command I need. The only difference, guys, is that instead of typing 0.05, I need to type what? 0.90. So let me just go there and change that real quick. And I get a z-score of 1.28. So on the picture, that's the answer, right? Z equals 1.28. So if you had a bone density higher than 1.28, then you are in the top 10%, I guess, of bone density scores. That's what that means. Okay. So z-scores tell you how far away you are from the center, from the mean. Okay, great. We've been pushing around numbers all day long. We haven't done what we usually do in this class, which is solve problems. We want to talk about situations. Oh, we solved a math problem, right? But I'm talking about, we want to apply mathematics. That's what statistics is, okay? So I'm going to jump to page 268 right now in the book, and 270. And this is the section where we're going to spend a lot of time on over the next couple of days. 268 has some good problems. And so as an example for you, I thought I might start with problem 22. They're talking about Air Force pilots. And you might say, well, why? What do Air Force pilots have to do with, what we're studying now? Well, the fact is, okay, things like height and weight, if you were to graph all the possible heights, all the possible weights that people have, you get a really nice bell curve. Matter of fact, there's some information here at the top which helps. And I still remember this. This goes back, so I don't know, I probably haven't told you guys, my wife is an identical twin. Did I ever tell you guys that? Oh, okay. So her twin, the way we met actually was at a medical school party. Now, I wasn't being a medical doctor. Neither was my wife, okay? But her twin is a pediatrician. She said the whole time through medical school, she kept talking about, Lana's boyfriend, me, because I'm the average man they always talked about. Why? Because look, the height's 69.5. That's me, 5'9". Well, I was 5'9.5" back in the day with the hair. So now I'm like a lofty, not as lofty 5'9", right? But that is the mean, the average height. There's plenty of you guys that are taller than me. There's plenty of people that are shorter. For females, notice that the average height, 63.8 inches, right? So what's that? 60 inches is 5 feet, right? So about 5'4". So you could argue that my wife and I, we're like, where are we on the bell curve? Like right in the middle, right? There's plenty of people taller, plenty of people not as tall. But this comes in when you're going to do things like build an airplane, right? When they build airplanes, they want to make sure that most people don't bump their head when they sit down. If you're on the tall side, right? That's something, like my brother-in-law, he's a pretty tall, he walks around like this. He's learned over the years, He knows, you got to go down someone's basement, he knows not to stand up too straight. Some of you taller guys know what I'm talking about, right? So anyways, U.S. Air Force requires that pilots have heights between... Now, why do they want them to be at least 64 inches tall? Well, maybe they have, in order to be able to see all the instruments and reach what they have to reach, maybe they need a certain height. But why would they not want them to be taller than 77 inches? Maybe that's some of the reasons that I'm talking about, right? You might not quite fit. So if they make these requirements so that you fit in the planes, that's one thing. But will they get enough pilots? Right? So part A says, find the percentage of women that are going to meet the height requirement. What did we say the mean was? Well, the mean of the standard normal distribution is 0. But see, this is interesting. This is the first time we've had a mean that's different than 0, right? It says the mean is 63.8 inches, right? Let me show you what this looks like, guys. We're going to do this. We're going to go here, and we're going to say, okay, women's height in inches. Actually, I'm going to do this. I'm going to say this. I'm going to say, let X equal women's height in inches. And I'm telling you that X this is a normal random variable. Now notice there's one word I did not use. I did not say standard normal distribution. I didn't say that. I said normal. What does the word standard mean? If you say standard, then this is your picture. If you say standard, your picture looks like that one, but the difference is that the mean is 0. But see, for women's heights, there's an average height too. But what's the mean? They said the mean is 63.8 inches. Are you with me on this? Okay? They also gave me the standard deviation. Standard deviation is 2.6 inches, right? So if I go up 2.6 inches, I'd be right here. That'd be like 66.4 inches. That's not uncommon. And if I go down 2.6 inches, I'd be right here. So that'd be 61.2 inches. That's not uncommon either. Right? Yeah. So by the way, my daughter, she's done growing now. I mean, she's 17. But she's on the left of the mean, for sure. Whereas my wife is just to the right. And just, people fall all over. We can go around and talk about height. Right? Okay. So what's this problem all about? The problem said, that I'm working on now, it said, that's the Navy pilots. Let's go down to Air Force. Find the percentage of women meeting the height requirement. Heights between 64 inches and 77 inches. Where's that? Well, on the picture, 64 inches would be just barely to the right of that line. That's the mean, right? So here is 64 inches. Now, where's 77 inches? That'd be a really tall woman, right? Because 72 inches would be 6 feet tall, right? So way over here somewhere is, what did they say the upper bound was? 77? Wow, 77. That'd be 6'5". So the question is, what percentage of women fall somewhere in here? Right? Okay, so let's do that. How do we compute it? Well, you don't know what to do. What you do is this. We're going to do a transformation of this problem to a standard normal distribution problem. In other words, what I have to do is I have to find the z-scores that correspond to each of these. And there's a formula I'm going to use. The formula is z equals, here it is, x minus mu over sigma. Actually, we've seen a formula like that once before. Back when we did z-scores back in the early parts of chapter 3. So how's this work? Well, you know some of this stuff, right? What's our mean? Mu? 63.8. Right? So I could say z is x minus 63.8 divided by, and what am I going to divide by? It was 2.6. That was given, okay? 2.6 inches was sigma. So they have to give you the mean and standard deviation or else you can't do this. But once you do that, watch what you could do. So we're going to do this. Z is x minus mu over sigma. So for the first one, the 64, let me try that. Z equals 64 minus 63.8 over 2.6. And I'll have to work out what that is. So let me do that on the calculator. By the way, if you try to do it all in one step, a little caution, you're going to want to use a parentheses for the numerator. So I'm going to open parentheses, and I'm going to say 64 minus 63.8. I'm going to close parentheses, and then I'm going to divide by what? 2.6. And so it tells me that that z-score is 0.77, let's say, right? So on the picture, guys, what we're doing here is we're finding one z-score would be 0.77. Can you guys find the other z-score? What am I going to type? This one was 0.77. The other one, I'll do z equals, the only thing I have to change is what? The only thing I have to change is that 64 should be what instead?
I got 0.077.
That's a better answer. So did I, right? I just didn't write it down right. Yeah, 0.77. Thank you. 0.077. Thank you. But this other one, 77 minus 63.8 divided by 2.6. Let's work that z-score out. So if I go to the calculator, I'll type the same thing in, but instead of that 64, I'm going to hit 77. So that z-score is 5.07. And so now, to finish the problem, you can hit normal CDF. Bye, Amy. Sorry about that. Thank you. Normal CDF is choice 2. And we're going from 0.77 to 5.07. And that probability, it says, is 22%. So only 22% of the women have heights in that range. And we are past time, guys, so I'm going to stop here and we'll continue with this stuff tomorrow. At least you've seen one example of kind of the kinds of problems we're going to be solving. We'll finish this problem next time.